This question asks you to populate this Venn diagram, and it tells you that all of the numbers in the Venn diagram, which are these here, are between 0 and 1 to 3 decimal places. So that can be 0.001 right up to 0.999, which is quite a lot of numbers. So they are all the numbers that are in this universal set. The second part asks you to numbers that round from to 0.7 to 1 decimal place. So that really means that you're going to take your 0.7 and round it up by 1 decimal place to 0.8 and down by 1 decimal place to 0.6. So kind of in between 0.7 and 0.8 is 0.75. I'm going to add a 0 on the end because it asks for 3 decimal places. And between 6 and 7, or 0.6 and 0.7, I'm going to say that's 0.650, again to 3 decimal places. So set A in here can be 0.750 maximum, starting at 0.650. But I have to be careful, because in truth 50 can round up to 0.8. So I'm going to amend that one very, very slightly, and I'm going to say, well, in truth I can go to 0.749. So it's just one less than that. Okay, so that gives me my values for that. So I'm actually going to make a mess of this and hopefully rub that out there. Great. The next thing that I'm going to do is I'm going to change colour, and I'm going to look at B. And inside B I've got the numbers that round nominally to 0.750 to 2 decimal places. So I can actually say, well, that's going to be 0.76, 0.74, and again back to 3 decimal places is going to do this. I look at the intermediate values and I say the number that is halfway between 0.740 and 0.750 is going to be 0.745. Similarly, between 0.750 and 0.760, I can say that's going to be 0.754. So in B here, I've got a minimum value of 0.745 and a maximum value of 0.754. And I'm going to rub this out now because I need the space. So the numbers that can actually occur in this intermediate portion here, what we call the intersection, there are the numbers that are in both of those A and B circles. So that could actually be anything from 0.745 right up to 0.749. If I was to list out all of these numbers and list out all of these numbers, these would be the numbers that were common to both. Now, the only thing that's left for me to do is to say, well, what is left over? Well, that's going to be anything that is going from 0.001 up to 0.649, one less than that value. So that's a 5. And also in here, anything that is a bigger than this value here. So it's going to be 0.755 up to 0.999. So this is a perfect example of really how not to set out your question. but as I'm limited for space, I've had to kind of fill a lot of detail in big text. So my answer for the first one, which says work out the possible number, a possible number with 3 decimal places that is in the shaded area, it's going to be anything from that set, and that's going to be my answer that goes here. Okay, it says also here work out a possible number with 3 decimal places that is in the shaded area here. That is going to be all of these numbers here. So it could be a number that is, if I just bear with me a second, just move that up a little bit. So that is going to be a number that is 0.650 all the way up to 0.749. Okay, okay, going to move now. It says work out the possible number with 3 decimal places that's in this shaded area. This shaded area, you might recall, we said was 0.750 to, hang on a second, let's just tidy that up a little bit because the writing's not particularly clear. 0.750 all the way up to and including 0.754. Right, what is left out on the outside? Well, that was everything that was 0.001 to, if I remember rightly, 0.649, and everything that was above and including 0.755 up to 0.999. So that actually is a really tricky question that requires... Okay, we've got a trapezium here, and the thing about trapeziums is there's always going to be 2 sides that are parallel to each other, and that's going to be this one, S to R, and this one, P to Q. So, what do we know about this? It tells us that they're parallel to each other, and P to Q is on the x-axis, which is just here. The y-coordinate of S is 8. So S is going to have an x value and an 8 here. What I know about P is it's going to have an x value and a y-coordinate of 0. What I know about Q is it's going to have another x-coordinate and, let's tidy that up a little bit, x-coordinate and another value of 0. And R is going to have an x-coordinate and another 8 value of y. And what I need to find is the values of x. What it tells me is that the length P to Q is longer than S to R, just here. And that's something that gives us a fairly indefinite answer. It tells us there's going to be more than one, because it doesn't tell us it's so many times bigger, it's just that it is bigger. And it asks us if the total area is 48 units, to find a particular set of points that satisfies all of these criteria. So we need to find those x values. So just thinking about the area of a trapezium, the area of a trapezium is a half times by the height times by A plus B, where this is A and this is B. And what that actually means for us is when we start to interrogate this diagram a little more carefully, it tells me that the height here, this height here, is actually this 8 value here. So I can say with fair confidence that's going to be 8. And I'm going to, instead of saying A here, I'm going to say that's length SR, and instead of saying B here, I'm going to say that's length value PQ, where I know that PQ is longer than SR. So I'm going to say now that that I'm going to rub out this value of A here, and I'm going to say, well, I know that that is 48. So I'm going to take the divide by 2 to the other side. This is going to come to this side, become a times by 2. This is going to come to this side and come a divide by 2. So at the end of the day, if I move all of those numbers over, what I'm going to end up with is I'm going to end up with 12 equals SR plus PQ. So there's a whole different variety of combinations of these numbers, lengths at least, but remembering that PQ must be bigger than SR. So for example, if I said, well, I'm going to say that's 5 and that's 7, they're both going to add up to my 12 here. So if I said now I need to start thinking about some of the numbers that I'm going to put in, I'm going to decide to start here, and I'm going to say, right, well, this, I'm going to let that be 2 and 0. Now, I'm going to tell you that PQ is 7, so I'm going to add 7 onto this 2, and that's going to give me a 9 right here. So the difference from here to here is my 7 here, just like this. Okay, so I've now got the coordinates of the length P to Q. And it looks to me as though S is a little bit further along the x-axis than P was, and I'm just going to say, well, let that equal 1 more. So I'm going to rub this one out here, and I'm going to replace this with a 3. And I know that the difference between here and here is my 5 from here. So that's going to be 5, which means that this is going to be an 8. I can now fill out these values down at the foot of my table here, and I can rub these out, these little lines here. So just take that out there, if I can remember how to do it. No, it won't do it. So I'm going to fill in these values here. I'm going to say the value of P is 2, 0. The value of Q is 9, 0. The value of the R coordinate is 8, 8. And the value of S is 3, 8. And that completes the question.